Welcome to EDU World Space.
In this exercise, we have a crate that has a mass of 200 kilograms and sits at the flat bed of a truck. The coefficient of static friction between the flat bed of the truck and the crate is equal to 0.3, and we want to know what is the shortest amount of time dt that it can take for the truck to go from rest to the speed of 60 kilometers per hour, so delta V is equal to 60 kilometers per hour, such that the crate does not slide at the flatbed of the truck. So the concept that we need here is the concept of static friction.
And force ratio frac FA, FB equal frac
So
0.10,
we have static friction
fractional result.
when the surface
FA, FB.
and the
Would
object
you like a PDF version of
is
this explanation
on the surface are at rest relative to one another. So in our case, we have a crate that is at the flatbed of the truck. If the crate is moving with the same speed as the truck, that is, if the crate is at rest relative to the truck, then we will need to use the concept of static friction. Now, basically what we have is that the maximum value of static friction, the maximum value is equal to the coefficient of static friction times the normal. And the normal is the force that the surface exerts on the block. Okay? So what we have is that this force is not constant. And what happens is that if, consider that this here is the friction force, and as the truck starts to accelerate, the force, the friction force, starts increasing with time. That's the force that makes the crate accelerate as well. And then it reaches a maximum point, and after that point, the crate will start sliding, and actually the friction force will decrease a little and allow the crate to slide at the flat bed of the truck. So what we need to find is what is the maximum acceleration that the truck can have such that the crate does not fall off the flatbed. Okay, so we have that the acceleration is equal to delta V divided by delta T. What the exercise asks us to do is to find the minimum value of the time such that the crate does not slide. Now, finding the minimum value of the time is equivalent to finding the maximum value of the acceleration. So let's do it. Let's draw a free body diagram on the crate. So here we have the crate. The forces that act on the crate are the gravitational force, mg, acting downwards. We also have the normal force, N, acting upwards. And we have the friction force that acts to the left. Now, since the crate is not moving in the vertical direction, the normal is equal to mg, meaning that the friction force is, the maximum friction force is equal to mu s times mg. Now we know that the friction force, since it's the only force in the horizontal direction, is equal to the mass of the crate times the acceleration. And since we want the maximum acceleration, we also want the maximum frictional force. And we've already said that the maximum frictional force is mu s mg. So the m's cancel out, and the maximum acceleration is equal to mu s times g. So this is 0.3 times 9.8 meters per second squared. So the acceleration is 2.94 meters per second squared. Now let's find the time corresponding to this acceleration. So we know that a is equal to dv divided by dt. So delta t is equal to delta v divided by the acceleration. Now delta v is 60 kilometers per hour, and we have to divide it by 3.6 kilometers per hour per meter per second in order to obtain a value of the change in speed in meters per second. So it's 16.67 meters per second. So we have 16.67 meters per second divided by the acceleration of 2.94 meters per second squared. So delta t is equal to 5.67 seconds. So this is the minimum value of time that it can take for the truck to accelerate from 0 kilometers per hour to 60 kilometers per hour and not have the crate fall off, which concludes our exercise.